Guys, today we're going to be talking about a new data structure called a try. And so, if you've ever heard of somebody trying really hard in a video game, it's not really good at all. Uh, a try is a tree, but it's interesting. It's an interesting tree because instead of you holding the value of the tree, like the value of the node in the node, the value of the node is actually held by its position in the tree, which is really weird. It's a kind of weird concept, but these are really neat. They're really useful. So, for example, here's a try constructed with a few different words: I, A, T, Ted, ten, and N, with one N, one with two N's. And so at each node, you can think of it as having an array of 26 pointers. Now, in reality, there's ways of not needing to have 26 pointers. You could probably use a linked list or something like that. But just imagine it conceptually. Every node has 26 pointers, one for A, one for B, one for C, one for D, so on and so forth. And if the pointer is null, that means there are no English words in that direction. If it's not null, then there is a word in that direction. So what does that mean? So, for example, let's say that let's say you've already constructed this try. How you construct it's not that difficult, but it's already constructed. And you're on your cell phone, and you do like some predictive texting, right? Like you pull up your little Swift key here, and you type in TE. Okay, so it is predicting the word that I'm going to type is tell, Tell. Okay, which is obviously not on the list here, but given the data structure here, if we entered TE, the word that it should predict that we're actually going to type is 10, because when they constructed this try, the word 10 appeared 12 times in the training documents. Do you guys understand that? So, what you trained it on, getting training data is kind of a controversial issue these days, what with AI and all. Reddit basically shut down all public access to the Reddit corpus of text online because it's one of the greatest sources of human conversation data out there. So a lot of AI companies were training Bridges. Even Bridges had a Reddit interface, right? And they were training their AI models on the words of everybody on Reddit. And so the Reddit people wanted to monetize that. So they shut down all the API key access, except in limited circumstances. And that was why there was that big moderator protests and things like that. Because how do you find out what words are more common than others? You could use the words of Shakespeare, but then your text predictor on your cell phone here is going to be like, "Prithee, thou art a braggart and a foul knave." You want it predicting, the way that people talk, right? So it's autocorrect. Not necessarily autocorrect. Autocorrect is like if the word's not in the English dictionary, but more like if you've typed a couple letters, what word do you think it's going to be? And so if you type in T, the most likely word within the subtree here is still 10, TEN, but the second suggestion would be 2, TO. And so basically you can iterate down through that tree for wherever you are. So when you're typing a keyboard, you can type SWE, and then the try that you've constructed for the English language might have swear, sweet, sweat, and based on the corpus of material that you train it on, it would knows which words are more often. Is sweet more common, or sweat, or swear more common, right? And on Reddit, it's probably swearing, but in real life, maybe sweet. I don't know. And so it'll suggest the most likely word. And then if you have a personalizable keyboard, then it'll actually remember what words you type. And then like autocorrect is like part of it. Autocorrect's beyond what we have here. But it could do things like, well, what if they type one of the letters wrong? You know, like I typed in BEC in my 12 o'clock class, BEC, and I was expecting it to predict because. And in fact, because was the second suggestion. But when I typed BEC, anyone want to guess what word it thought it should be? It's not a word that begins with BEC. Because it'll say like, well, what if the first letter is wrong? What if the second letter is wrong? What if you left off a word or a letter? What if, right? Anyone want to guess what word? Because it's learned my typing habits from helping students do vectors and stuff. That is correct. Yeah, vector, right? I typed back. I was like, you mean vec, right? Obviously, yeah, but because was the second most popular one. So you have to kind of work with, like if you're talking autocorrect, it's a little bit beyond what we're talking here. Okay, so here's another try here. So here we've got several different words inputted. And in this one, instead of having a count for the most likely, we just have a Boolean. And so each data node only has one data payload, which is, am I a word or not? Okay? So SEN is not a word. And so its Boolean would be false. But for SEND, that's a word, so its Boolean would be true. And so there's ways you can compact these things way down. And what's nice about this is if you think about it, like if you look at like the dictionary on a Unix machine, pull that up. You can actually compress it like quite well if you use a try. So where is it? Like locate, dict, pipe through, grep words, something like that. I got user share dict words. Let's vim that. And so you can see here, these are all the words in the English language, at least according to this file. There are different dict files, and that's dict with a T, dict files. And so there are small dict files, big dict files, medium dict files, and you can choose which one you want to have installed on your system, because this dict file is what is used for like spelling, spell check and things like that on a Unix system. So you can kind of choose, like, do you want to be more permissive and have a big dict file, or you can be only the most common English words and have a small dict file. It's up to you. I think I have the medium one installed here. So you have viscountess, viscountesses, things like that. And so look at how much redundancy there is here. You guys see this? VISC, 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 VISC. You see this? All that is redundant. If you store this in a try, and if you can get that cost down, so you don't have 26 pointers off every letter, or worse, if you have apostrophes, capital letters, things like that. If you have just like maybe a linked list or something like that coming off it, then all this can compress down really well, because you only have to store the letter V once, and the VI once, and the VIS once, right? And so all these guys that start with VISC, all of them are going to, in the try, have VISC, and then they're going to branch off from there for viscosity, viscount, things like that. So, so you can actually store the entire English language, so to speak, the dict file. You can put it all into a try, and that means that when a user types VISC, then it will autocomplete. And you can hit tab and it'll fill in viscountess or whatever based on whatever it thinks that you are trying to say there. Pretty cool, right, guys? So, so here we have, a little bit of the English language stored in a try. And so the root node's blank, right? It doesn't it represents the start of a word. It's like the dollar sign in regular expression, pattern matching. And so if it has a B child, that means there are words in the English language that begin with B. But its A pointer is null, its Z pointer is null. So there are no words in the English language that begin with A or Z, at least according to this try here. Okay. And so when you iterate down, to the B pointer, then we know that this node represents the letter B at the beginning of a word. And then when we iterate recursively down into the A pointer, we know that represents ba. And because its leaf Boolean is false, we know that there is no word in English that is ba, ba. And then A has two kids, L and T. Greetings, child.
Dad.
What's up, girl?
Why is there a dead roach?
Yeah, I just left that as a present for you, so I thought you'd enjoy that.
In here, you might eat it.
Louis in here. He might eat it. I don't think he eats dead roaches, girl.
I don't know. He tried eating a dead spider.
I don't know.
A live spider.
So, and then when we get down to BAT, we see that BAT, the Boolean there is set. So bat is a word in the English language. BAL is not. BALL is. So you can see here, do is a word, doll is a word, dork, dorm are words, but DOR is not. SENS is not. SEND is. SENSE, sense is. Okay. You guys understand tries? You can either have it be true or false, or you can have it have a count. Okay. So, that is probably the last data structure we're going to learn in this data structures class. So we've learned vectors, arrays, decks, stacks, queues, linked lists, singly, doubly, binary search trees, heaps, hash tables, tries, 10. You open this for you? Am I going to get cat-like juice all over my... No.
Yes.
This is a terrible idea. I'm going to get gravy all...
No, it doesn't.
All right, 1 second, people. And I'm back. Yeah, I was not about to open that cat food over my shirt. I'm going out to board games tonight. Can't be smelling like cat food. All right, so those 10 data structures are all that we're really going to cover this semester. But here's the thing. In real life, you're probably not going to write your own data structure most of the time. We have you guys write linked lists and binary trees in this class so that you get good at pointers, because you have to know pointers. And writing linked lists, writing data structure is good for you, like mentally. So you learn how pointers work and learn how to understand them and realize, you know, if you set a pointer to be null, it doesn't segfault. You have to dereference a null pointer, things like that. In real life, I don't write my own linked lists. I haven't done that since the 90s, you know. I just use, you know, the list class. I don't care that I could probably write one that was faster. I'm not confident I can write one that was as fully featured, as bug-free. You know what I mean? Like, I could, you know, I value my time. I optimize my time, right? So you can optimize CPU time, and there are times where that's useful, but I like optimizing my time. You know what I mean? And so I just hashtag include list and make a list and call it a day. And that's it. You know, but here's the thing that you will do, okay? So even though you're probably not going to write your own binary tree, linked list, vector, you know, hash table, that kind of thing, a lot of times you're going to put multiple data structures together, okay? And that is something that you're going to use. And it's probably something you're going to need for your next RPG assignment, for example, right? And so once you kind of understand data structures, once you understand what they're good at, and once you understand what their trade-offs are, you can start using them like puzzle pieces. So that's really what separates like bad programmers or poor programmers or new programmers, however you want to put it, from like good programmers, okay? A good programmer, like 99% of the time, we're not going to write our own vector class. We're just going to hashtag include vector and call it a day. Now, there are people that absolutely need maximal performance, people that do like high frequency trading, things like that. In gaming, there's something called the EA standard template library, where again, I'm not going to write it myself. I'm just going to include their vector because under certain circumstances, it's faster than the standard library vector. But like a new programmer will be like, I'm just going to write my own. I'm going to write my own linked list class. I'm going to write my own sort function. And it's like, more power to you, kid, but you know, I don't trust your linked list not to segfault. I don't trust it to not, you know, did you write a move constructor? Do you guys know what a move constructor is? Do you know what a move assignment operator is? Do you there's a lot of pieces. Do you have iterators? Like there's a lot of pieces to it. And in fact, we're going to talk about move operations in just a little bit. But experienced programmers are like, nah, I'm not going to write my own sort. I'm going to call std sort. I'm not going to write my own list class. I'm going to call std list, unless there's a really good reason to. We just reuse all the old stuff, and we use them like puzzle pieces, right? I'm going to take a vector, I'm going to put it together with a binary search tree, and I'm going to make it a hash table, right? I've got a vector, and it's a vector of binary search trees. This was what we talked about on Monday, right? And we made our own hash table class
There's
with
a
like
pinata and we broke it open and they were
6 lines of code.
and they were homework passing them and I got 3 of them, but I gave one away to because I don't really use them. They're more candy than I got on Halloween.
I will bring some in here.
I shared it all with my friends.
Well, good. I don't want to eat candy anyway. Okay.
They had shoes. In homework classes.
Right. So in the last class, we built a very efficient hash table. Very simply, we just made an array, and every element of the array is a binary tree. It's a composite data structure. It's a data structure made by combining 2 data structures together to do something more interesting. So rather, you guys get what I'm saying here? Rather than like, I'm going to make my own vector again. Like, why? I don't care. Like I said, 99% of the time, I don't care. 1% of the time, maybe, there's some need, I want to have an uninitialized vector, or something like there's reasons. I'm not saying there's not reasons, but in reality, what you're going to spend most of your time doing is taking these puzzle pieces and clicking them together to do something really neat. So for example, if you take 2 stacks, that's how undo and redo work. Okay? So you guys know redo, like Control Y. Control Z is undo. Control Y is redo, right? Here's where the keys are on the keyboard. Right? There's Z, there's Y. You guys have used undo and redo, right? When you undo something, like as you take actions go onto the undo stack. And then when you hit undo, you pop off the undo stack and you push it onto the redo stack. And then when you redo something, it comes off the redo stack, it goes back onto the undo stack. And so if you go undo, 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 1, 2, 3, pop and push, pop and push, pop and push. Now if you take a new action, you've diverged from the timeline, the redo stack gets cleared, and the undo stack continues to build. And so it's just a pair of stacks. That's all you need to do to get undo and redo working. Back in the old days, they only had undo. They had no redo. And so redo was implemented just with a second stack that takes the actions of the undo and puts it on. So the compiler that I wrote back in the day was mostly a queue and a stack working together to parse the code. You just used undo. If you guys have the opportunity to take a compiler class at the junior level, I would highly recommend it. They used to be mandatory. It used to be sort of the filter class, the weed out class, the class that was required that all juniors take that like gets rid of the unworthy. And in fact, at UCSD, it had the same course ID as organic chemistry. So the organic chemistry, I think, was like, I don't remember, it was like 131 or something like that. 130, something like that. And Chem 130 was like OChem, and like CSci 130 was like compilers. And they were both like juniors' time to see if you learned anything as a freshman and sophomore, because it's getting real now. And 20 weeks, 1 homework assignment. 1 homework assignment, 20 weeks. Every week you had something due. So it's not like they waited for 20 weeks for you to finish it, because nobody would. That would be a disaster, right? Every week you had to work on it and you had to improve it every week, adding a new feature every week. And they walk you through the building of a compiler. They don't just turn you loose on it, right? Like you learn the theory of compilation and things like that. But every week you're building it, And so if you have a bug in week 1, you still got a bug in week 9. You know what I mean? Like it's still crashing for the same reason. Like they don't give you, like, I think maybe because it's 2 quarters, right? So if you take the first quarter and then the second quarter, I think they give you a checkpoint in between, because like not everybody takes them back to back. And so they're like, here's the part A version when you do part B. But basically, I didn't even use that because I was comfortable with my code. And so, it was just 1 week after another, building and building and building, making it more and more complicated, until at the end of the day, I could write a program in this made-up nonsense language that the professor designed. This is just a language that nobody uses. And you could type that source code into a text file in Vim. You could compile it using my compiler. It would generate assembly code, and then that would turn into an executable, and then you could run it. It's a cool feeling. And I highly recommend you guys do it, because in that class, you bring everything together. You bring data structures. You bring your debugging skills and things like that. And it teaches you how to architect a bigger project than what you're used to. Because in this class, everything you do is really small. Like a page or two for most of the homework assignments, right? RPG 41, like some people have like 10 or 20 pages. Tiny, right? In the greater scheme of things, a 20-page homework is tiny, right? And so getting experience working on something bigger is a really good thing for you guys. So I highly recommend you guys take it, even if it's not required anymore. It's good for you. It's like vegetables. So you don't like it, but like it's good for you. Another thing you guys can do while we're on this topic, it is cool. It is cool. And if you look at like John Carmack, our Lord and Savior, JC, he, when doing Quake, he wrote a new programming language called Quake C, and he wrote a compiler for Quake C that would compile to this sort of assembly code. That he wrote an engine that would read the assembly code and then execute it. So when you modded Quake, you weren't doing it in C. The server and the client were done in C, but the mods were all done in this made-up programming language that he made specifically for Quake. And so you would write it, and so the mods could be distributed. It was safe. You couldn't really hack people's systems by passing mods out to them like you can with most mods that are jar files or DLLs. In Quake 2, they moved to the DLL system, which is much more vulnerable from a security standpoint. And he just did that, just for fun. Like, I'm just going to make up my own language and a compiler and a bytecode interpreter, and it'll be fun. It'll be a fun exercise. And so John Carmack, absolutely amazing. And that's the kind of thing you can do after you've taken a class like that. But on that topic, another thing I want to mention is there is a tutorial center on campus. You guys remember Min Curley, that guy? So Min Curley, is he here right now? He's not. So the tutorial center is now hiring tutors. I will put the link for this on chat. And I want to say that TAing computer science is also one of the best ways of learning. So put this up on CSI 41, Help Center. There you go. So I was pretty good at computer science at the freshman and sophomore level, but I started TAing when I was after I took 41, then I started TAing for 41. Sophomore year I started TAing. And it was good. It was good for my development. Because in every foreign language, you have reading, you have writing, you have speaking, you have listening. And that's true whether you're talking about Japanese, Mandarin, French, or C++. And a lot of you guys are good at writing code because that's what we train you on. That's what we practice, and you get good at the things you practice. You're not good at reading code and debugging it. And so, or listening to somebody explain their code to you, because that's a skill that you just don't use in most homework assignments. And so when you work in the tutorial center as a tutor, which pays competitive rates of minimum wage, you can work as a minimum wage tutor. Can you call your friends? Yeah, absolutely. Get ready for board game night, girl. You don't want to go to board game night? All right, you don't have to go. The tutorial center, you'll sit there and students will come in with homework that doesn't work, and you got to learn how to read it. You got to learn how to very quickly look at code, parse it, understand it. Maybe you don't know exactly why it's crashing, and then start debugging it. And all of those are really good exercises for you. It's a really good experience. Because when you go to work for a big company, most of the time, they don't do greenfields. They sometimes do. But most of the time, you're going to be working on their product. The product might have 1 million lines of code in it. You have no idea where anything is. You don't know how to read it. You don't know how to understand it. and you're a liability to the company because any change you make is likely to be, worse than what was before, right? And so getting those skills I highly recommend. And even if you guys don't want to work in the tutorial center, you might notice that several of the people online have the alumni tag and things like that. Like Hazelton, you'll see pop in here, and he'll help students and things like that. So that's another option you can do. Just helping students, in future years with their CSI 40 and 41 work is actually a really good learning experience as well. And if you want to professionally work as a computer scientist, you have to get good. Like you have to keep honing those skills and keep practicing and keep getting good. It's like I'm taking Japanese for fun, right? Like my whole goal of these 4 years, going on 5 years of Japanese, my entire goal, the reason why I'm doing this, I have 2 different tutors that I meet with every week. Took 2 semesters of Japanese. Why? So that I can go to Starbucks and I can order a latte in Japanese. Have the entire conversation be in Japanese. That's it. I have a very low bar for success. That's it. I can give them change, the whole thing in Japanese. That's it. But I'm not going to work professionally as a Japanese translator, right? If I did, my work habit is not good enough, right? Like I've got my Anki decks that I kind of half-heartedly go through. I'll do 20 a day, something like that, when I should be doing 100, right? I've been stuck on Wanikani level 3 for 226 days now, which is pathetic, right? My work habit is not good if I wanted to be a professional Japanese translator, right? I'm doing this solely to buy a latte in Starbucks. And it's good enough for that. So if you guys want to be a professional programmer and not just somebody who hobby, whatever's, if you actually want a job in computer science, you have to hone your craft. You have to keep working. Over the summertime, find a project that speaks to you, find something that interests you, and just code it up. I do summer projects most summers with my students. Join in on that. If you have no idea what to do with a project for yourself, what's your hobby, right? I had one student who's like, my hobby's weightlifting. I'm like, all right, write a simple program that'll track your gains. So every time you go to the gym, you run the program, you enter how much you squatted and bench pressed and things like that. Track your weight over time. You do different analytics, body weight, body mass, body fat index, whatever. A project using a Raspberry Pi, great. Yeah, Raspberry Pis are amazing. I've got Arduinos and Raspberry Pis. I got one literally hanging off my bookshelf right here. It's hanging by its Ethernet cable. It's just dangling in midair. Pis are great. There's a lot of cool stuff. And if you have no idea what to do, then buy a book. There's the Maker's Guide to the Apocalypse, the Zombie Apocalypse. And I'll have different project ideas you can do to build a Raspberry Pi powered spike traps and things like that. I don't know. They're actually spike traps, but you get the idea, right? Like a door opener and door closer and things like that. So they are much more expensive than they used to be. I think the price is a little bit more reasonable now. During the pandemic, there was a massive shortage of Raspberry Pis because there was a chip shortage everywhere. And so Connecticut, the Pi 5s, maybe you want to get a Pi 4, you don't really need. Maybe let's kick it back old school. Let's go with a Pi 3. Let's see what the price is on these things now. $80, and that's a kit. That comes with the power supply, a case, and the Pi. It's not terrible. So, does it come with an SD card? No. This one comes with an SD card. $100. Pi 4. Pi 4s are $150 for a starter kit. Pi 5, $170, $150. Maybe this one. I don't know. Oh, $100. That was just the Pi. No power supply though. No SD card. So you can probably get your own SD card and flash it and stuff like that if you want to do it yourself. Yeah, it's like $110 for a Pi 5 and or you can get like a Pi 2 even cheaper maybe. Yeah, there you go. Pi 2, $40. There you go. Pi 02, $21. Right. So these things like they don't have the power that a modern Raspberry Pi has. One of the really nice things about them is that they use very little power. And so you don't even have to have a heatsink or anything on them. These guys draw like 2 watts of power. And so you can just, and they're $40. If you break it, like, who cares, you know. The Pi Zero is like really underpowered, so I wouldn't necessarily recommend that. But you know, $20, like, you know, for the cost of like a meal, like an extra value meal at McDonald's, you can get a computer. These are actual computers, right? Like these are not Arduinos. Arduinos are like controllers that you can hook sensors and actuators to. Raspberry Pis actually run Linux, and it's got a gig of RAM. It's not a lot. The modern Pis go up to like 8 gigs, but a gig's fine for like basic projects. Like you can learn how to administer your own Linux box. You plug Ethernet into here. You plug. You get a little Wi-Fi dongle. It doesn't have built-in Wi-Fi on the Pi 2. Pi 3s and up have built-in Wi-Fi. Pi 2s, you have to get a little Wi-Fi dongle for them. You can plug in HDMI and hook up a keyboard, hook up a mouse, hook up a monitor, and you've got yourself a working Linux box for $40. You know, you have a spare SD card sitting around. You flash it with Noobs, which is the operating system, and do it. Okay. So, I would highly recommend doing something like that over the summer, because you need, like I said, you need to just keep staying on that grind. You need to keep working. If you're just like, oh, you know, I'm just going to take classes and get good. I mean, that's fine and all. It's like, you know, taking a Japanese class made me a lot better at Japanese, let me tell you, than a lifetime of watching anime. You know what I mean? Like actually taking a Japanese class is very useful, but you need to practice. You know, you need to stay on that grind. Okay. So that's my advice for you guys over the summer. Take IS-50. IS-50 is game dev. It'll keep you up in your practice, and you're going to learn some different kinds of skills than you learn in normal computer science. IS-50A is game dev. Okay, so composite data structures, like I said, it's just this notion that you take a vector and you make a linked list at every spot in the vector, or you make a linked list of vectors. Oh, look, you got a deck now. If you have a vector of binary search trees, oh, look, you've got a hash table now. Whenever I'm coding a game, I usually start from the perspective like, all right, what data structures am I going to need for this game? How should I hold the data? And like I was designing a game the other day where it would be like a castle defense, like orcs would be attacking a castle, and the players, there'd be like 3 players that are wizards, and they're like blasting the orcs, horde mode kind of style. I'm like, all right, how do I want to hold this data? You know, how do I want to do this? You know, how do I quickly tell, you know, when I fireball a spot, did I hit something? How do I see if I ran into something? You know, I can do a grid, but then the orcs are going to move, you know, like this. How do I want to do this? You know, do I want to be able to iterate across all orcs, like remove all orcs from play or give all orcs a buff? You know, what are the operations that I need to do? Right? What is the most common thing that I'm going to be doing? What's the most expensive thing I'm going to be doing? And you think about the data structures from that, and you build your solutions by merging different data structures together, usually. Like for your RPG 41 assignment, you probably had a doubly linked list for your initiative tracker, maybe a grid for the world, like some sort of 2D array for the world, binary search tree for the inventory system. So for your next assignment, you're going to have to take your previous RPG 41, and you're going to add more to it. So that'll probably be the last big project of this class. There might be one more depending on the timing. That'll be coming out next Friday. So next Friday, Gilded Roses due. and you're going to be given RPG 42. All right. Do you recommend one project per summer? Yeah, I would say so. And good to see you again, Prada. You'll have 1 week for RPG 42. So last RPG 41, I gave you guys 3 weeks, and nobody did anything for most of those 3 weeks. So we've learned our lessons. You're going to have 1 week to work on that. Yeah, it'll be doable. You've got a working project, right? And if it's not, well, you know now. So now you got 2 weeks to do it. As far as Gilded Rose goes, like I'm talking about here, like how do you do this so that it's fast? So for this assignment, so Nico, you still here? Nico, is the Gilded Rose like the name of like a shop in World of Warcraft, like on the Alliance side? I never played Alliance. Is it? Do you know what I'm talking about? Like, sounds like a tavern. Gilded Rose, Wowpedia is the inn in the trade district. Have you been here before, Nico? I've literally never played Alliance. I've never been to Stormwind. I've never seen any of these before in my life. Everyone goes there. Great. Okay. So the Gilded Rose. That's funny. So for the summer assignment, the fantasy is that you are the operator of the Gilded Rose Tavern, and you're going to have different items for sale. And it can include Sulfurus, the Hand of Ragnaros, right? Nico, you remember that one? The big fireball launching hammer. And so that sells for 222 gold pieces. What kind of inventory is this? It's the homework assignment. They have to basically run a shop, and so it's inventory. So you put things like an iron helmet and conjured water. All these things go up for sale. And then the kicker about the Gilded Rose assignment, and this is again inspired by somebody else. I didn't develop the Gilded Rose code kata myself. I just adapted it for this class. The notion is time can advance, and as time advances, some like food items will go bad and have to be removed from the store. And the way that it works is that every item has a sell-by date, and when you exceed the sell-by date, the value goes down by 1 every day that you're past the sell-by date. And if it ever hits 0, it has to be deleted. Now, the way that a lot of students have implemented this in the past is when the user says advance time by 1 day, they go through all 100,000 items in the shop and decrement the value by 1 if they've exceeded the sell-by date. And so if you have 100,000 days, which some of the test cases are like that, you have 100,000 items in your inventory, you got 100,000 days, go to the next day, 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 go to the next day. Now you've done 100,000 times 100,000 operations, and your code times out, and you get a 0 for that test case. Grandma's bread, yeah. Well, just conjure more food, right? Wizard, conjured food, conjured water. So if you want your code to pass all the test cases, you have to think about this, right? How do I do this? How do I make this code? How do I design this code so that I don't have to do an order in operation every time time advances? Yeah. So you've got a hash table. Hash table's got all the different items in it. Some of them are expiring, some of them are not expiring. What I would recommend doing is when you advance time, do absolutely nothing. The only thing you should do when you advance time is time plus plus. Just increment that time counter and you're done. You should be able to write your code so that you do nothing when time advances. Well, then how do I know when food expires it should be deleted from the inventory? Just wait. Just hold off on that. And then after 100,000 days goes by, when people say print out, everything you have in stock, you grab each thing in stock, and then you compute the price. And if it's expired, you delete it secretly without saying anything. Oh, that food's rotted, throw it away. Oh, that food's rotten, throw it away. Oh, that iron helmet rotted, throw it away, right? And so only when you actually are asked the price value of an item should you compute it. Once the items go into the hash table, I would recommend that you leave them there immutably. You don't change them. Don't change the value, ever. Just put them in, And then if you ever decide, oh, that thing's rotted, you can delete it. But that's the only thing you should ever do. You should never update the values in the hash table. Insert them, and then at any time you can compute the price on it because you know when it was inserted. And if you don't know, you should probably write that down, put it in your items.h when it was inserted, because the value of some items go up every day, right? Wine goes up in value every day. So if you know when it was inserted, you know what day it is, you know what its expiration day is, you do a little bit of algebra, compute its actual price. If its price has dropped below 0, you delete it. Otherwise, you just print the value. And that's it. That's a very fast thing. Because then the only operations you do is like when somebody says, hey, add Ragnaros to the establish a starting date and work off that 1/1900. Oh, the time just starts at 0 or 1. Maybe I think it starts on day 1. Is the first day. So it's just day 1, day 2, day 3, day 4. And then the items will say, I expire on day 8. And then once you pass day 8, the price of the value drops. If it's conjured food or water, it drops by 2 per day. Regular food or water drops by 1 per day. So, are there better materials? What about the economy? We don't care about the economy. But yeah, people can sell things to the shop. They can buy things from the shop. At the end of the day, when you quit the program, you report your sales, your total sales. I sold a total of, 10,000 gold pieces in this simulation. So stacks of copper, whatever, right? So, do you guys understand? So basically, when somebody inserts into the hash table, you insert order 1 operation, and then when you get the price, you grab the item, do some algebra to compute the new price. If it's 0, you delete it secretly without saying anything. Otherwise, you print the item and the price. That stops you from having to do an order n update every time advances. And that'll make your code fast enough to pass all the test cases. Okay. I've had students in the past try and do this without a hash table. Good luck. Yeah, you need the speed for this one. We definitely push up against the 3-second time boundary. Like I make the test cases run in like 2.2 seconds, something like that. So if your code's too inefficient, you hit the timer, you don't get the point. How's this going to be incorporated into RPG 41 game? Your RPG 42 game, you already did RPG 41. RPG 42, you have to have an operating merchant. So, I'm kind of getting you to do the work for that. Okay. And then the code that I showed you guys the other day, where you do future actions, where you can like have a grenade, pull the pin, throw it 3 seconds from now, it explodes. That's another thing you're going to have to do in RPG 42. We're looking to incorporate Pokemon into it in a non-license violating way, like Pal World, and we're going to do music. So those are the 4 kinds of things we're looking at right now. It's not finalized yet. You'll get it next Friday. No, you're not putting this into your RPG 41 now. Gilded Rose is just a standalone homework assignment. Everybody's got to do it, and it's auto-graded and everything. Okay. But yeah, you're probably going to put it into your actual game. Okay. Same groups. If you have issues with your group, let me know. I can move you. But that's it for today, guys. So thanks for coming out. I would recommend you guys, you've already done lab time for today. So I would recommend you guys work on Gilded Rose like right now. And if you're going to get stuck on it, get stuck early. But that tip that I just gave you guys, that when you advance time, basically you don't do anything. That should be good enough to you guys, and use hash tables. That should be good enough for you guys to pass all the test cases. Okay. Shouldn't be too bad, just a little bit of algebra. All right, guys. Thanks for coming out. Peace out.